Hello learners, I am Dr. Arunkumar, faculty member, School of Management, SASTRA, Deemed University. In this session, I am going to discuss about data preparation and how to do data editing, coding, and data entry. So the learning objectives of these sessions are, number one is we will be demonstrating the ability to get data ready for quantitative analysis. Next one, we will be describing the various processes by which one can get a feel for the data in a study. The third learning objectives here is describe the means by which the reliability and validity of measures can be assessed. We call it as goodness of measure. So that gives a complete preparation of the data for our analysis. So to start with, let us understand what is data, getting the data ready for analysis. After you see as a researcher, you get the data obtained through the questionnaire. They need to be coded, isn't it? They need to be coded. And it has to be keyed in, and it has to be get edited. That is the categorization scheme has to be set up before the data can be typed in, whether it is a categorical variable or nominal variable, nominal variable or ordinal variable, like that. We need to categorize that. Then we also look at the outliers, inconsistency in the data, and is there any blank responses we need to check on that. If any have to be handled in some way, each of these stages of data preparation is discussed below. We will be giving you those inputs in this slide below. The slide here. So now let's look at what is coding of and data entry is all about. So what is data coding? Okay, assigning a number to the participants' responses so they can be entered into a database. So let's the first step in data preparation is data coding. Data coding involves assigning a number to the participants' response so they can be entered into a database. So for our convenience, sometimes the researcher will tend to use the Google survey forms, all those things where already the data has been we can extract the data in an Excel form, whereby you don't need to enter or code the data. It has been already coded. But even though if you have your Excel sheet observed into SPSS, then you have to recode according to your the structure of your questionnaire. So that is very, very important in coding of data. So now let's look at the coding the responses in using SPSS. So if you look at the questionnaire here, okay, here we have used a Likert scale. So the Likert scale, using the Likert scale, I think they used a 5-point scale here, and 1 is completely disagree, 2 disagree, and 3 neither agree nor disagree, and 4 agree, and 5 I agree completely or strongly agree. Like that we can code the responses. So that is very important. Once we code the responses, it is easier for us to enter those data into SPSS data sheet. So you can see this entering into SPSS data. So 1, we all know that it is strongly disagree, and if it is 5, it is strongly agree. So like that, we need to code the data and enter into the data. Okay. So moving further, let's also look at the data entry, how we can able to enter the data. Let me also demonstrate how to enter the data. So by looking, so let's have the definition of data entry. So once after responses have been coded, they can be entered into a database using SPSS software. Raw data can be entered through any software program, but we here as management students, we're supposed to learn SPSS software. Let me demonstrate how data can be entered using SPSS software. Yeah, this is the SPSS data sheet. I'm using version 16 of SPSS, and there are a lot of versions, and now IBM has bought SPSS, and you have SPSS student version for your learning purpose. You can download going into exploring Google by giving your credentials, and if you open the SPSS data sheet, you can see here there is a data view and variable view. So variable view is this which I'm displaying right now, and if you look at the variable view, first one, let me enter the demographic characteristics of the respondent, which is captured through the questionnaire. So when I use the SPSS software, let me type age of the, you should not give space here, age of the respondents. If you give space, it won't accept, but so make sure you don't give space, and by default, here you can give the space in the label column, the name column. You should not give the space. Here you can give space, age of the respondents. And if you are having different category of age, for example, let's talk about one. It's between 12 to 80 is the category called one. Okay. And if you have two, then it is between 19 to 28, like that. And third, we can enter, that is 3 is that 29 to 39. Okay, so like that. And the fourth category of age group, we have categorized in our questionnaire which we have prepared, okay, on capturing the demographic details of the respondent. So 4, I am typing 30, 39 to, this is for a demonstrative purpose, 39 to 49, okay, like that. So I keep adding this 39 to 49. Here I supposed to, you can change this 38, you can type it 38, okay. So here I have I put 39, and next one is let me put the fifth category. The age group. It has been entered as like instead of here 39, I can put here 30. Yeah, here I can put, instead of 49, I can put 48. Okay. Next one is so I changed here. So the fifth category, I am typing here the fifth category. This one become 49 to 59 age category. Okay. So I think this values I have entered. One denotes the age category between 12 to 18, and second one 19 to 28, and 29 to 39, and fourth one is 39 to 48, and the fifth category 49 to 50. Then give OK. So it has been entered, and this is scale. You can change the scale because it's a categorical variable, so you can put this as nominal variable. Okay, all demographic comes under this nominal variable. And next one is you go to data view and look at the questionnaire here. So the variable will be reflecting here. You can see here. So the age of the respondent. So here you can type one. If you first questionnaire, you got age respondents from between 12 to 18, then 1. Then if it is 18 to 29, then you can type 2, like that. If it is 59 to 5, then you type 5. So like this, you can enter the data using SPSS software. So this is the demonstrative input from my end. Hope you understand how to enter the data. So using SPSS software. So to recap, there are two views. One is data view and variable view. In variable view, we type the questions here, and we mention, we input the values as well as the values we have to give the inputs, and also we have to check whether it is ordinal scale or nominal scale, depending upon the scale which has been given in our questionnaire. Are you clear about it? So hope this inputs make sure that you are very proficient with entering the data. So please, download SPSS software and try to, do self-learning so that you become an expert in SPSS software. There are plenty of opportunities, and it is a fundamental to guide you to get opportunity to big data analytics jobs. So the next, element which we are going to discuss about the editing of data, and in the editing of the data, an example has been given here. An example of illogical responses is an outlier responses. An outlier is an observation that is substantially different from other observations. So if you find any outliers, please remove that, edit that, okay? And sometimes what happen, inconsistent responses or responses that are not in harmony with other information, that has to be duly taken care. So that's very important. And illegal codes or values that are not specified in the coding instructions. So basically here, after the data are keyed in, they need to be edited. For instance, the blank responses, if any, have to be handled in some way, and inconsistent data have to be checked and followed up. Data editing deals with the deducting and correcting illogical. An example of illogical response is an outlier response. An outlier is an observation that is, substantially different from the other observations. An outlier is not always an error, even though data errors are, a likely source of outliers, because outliers have a large impact on the research results. They should be investigated carefully to make sure that they are correct. You can check the dispersion of nominal or ordinal variables by obtaining minimum and maximum values and frequency tables. This will quickly reveal the most obvious outliers. And for interval and ratio data, visual aids such as scatter plot or a box plot are good methods to check for outliers. She feels that for the efforts she puts into the organization, she does not get much in turn and has made a mistake in responding to this particular statement. Then the response to the statement could then be edited by the researcher. That's a way editing will be helpful for the researcher. And also there is one more component we need to discuss. It is about the illegal codes or values that are not specified in the coding instructions. If you look at the coding instructions, For example, a code of 6 in a question number 1, I invest more in my work than I get out of it, would be an illegal code. The best way to check for illegal codes is to have the computer produce a frequency distribution and check it for illegal codes. So not all respondents answer every item in the questionnaire. Omissions may occur because a respondent did not understand the question, if they did not know the answer, or were not willing to answer the question. If a substantial number of questions, have been left unanswered, it may be a good idea to throw out of the questionnaire and not include it in the data set for analysis. Hope this is my inputs towards editing of data. And next one is, let's talk about the data transformation. So what is basically the data transformation? A variation of data coding is the process of changing the original numerical representation of quantitative value to another value. Data are typically changed to avoid problems in the next stage. Clear? Next stage. When you going for analysis, data analysis process. For example, an economist often use log arithmetic transformation so that the data are more eventually distributed. If, for instance, let's talk about in data transformation, we have another type of data transformation. So the another type of data transformation is reverse scoring. Take for instance the perceived inequity measure. In that context, we can also reverse score the context. For example, let's talk about for example, we can recode. Suppose I'll give you an example. The perceived inequity measures of an organization. So perceived inequity is measured by 5 survey items. That is, first one is I invest more. So I invest more in my work into the organization, so I get much return. So it can be reversed. And also, if I take into account my dedication, the organization ought to give me a better practical training. So like that, depending upon the context, we can reverse the score. In general, the benefits I receive from the organization outweigh the effort I put in. So this score can be reversed. For the first, second, and fourth item, a score indicating high agreement would be negative. But for the third and fifth item, a score, indicating high agreement would be negative. But for the third and fifth question, the score indicating high agreement would be positive to maintain consistency. So that's about data transformation. Next one is like getting a feel for the data. We can acquire, a feel for the data by obtaining a visual summary or by checking the central tendency and the dispersion of a variable. So we can also get to know our data by examining the the relation between two variables. That can be very well explained in detail in this context, depending on the level at which a variable is measured. So We can see the table 14.1, which summarizes the relationship between the scale type, data analysis, and methods of obtaining a visual summary for variables. This table shows that depending on the scale of our measures, the mode, median, or mean, and the semi-interquartile range, standard deviation, or variance will give us a good idea. And also we can infer from this displayed table, depending on the scale of our measures, the mode, median, or mean, and the semi-interquartile range, standard deviations, or variance will give us a good idea of how the participants in our study have reacted to the items in the questionnaire. These statistics can be easily obtained and will indicate whether the response ranges satisfactorily over the scale. If the response to each individual item in a scale does not have a good spread, the range, and whether it shows very little variability, then the researcher may suspect that that the particular question was probably not properly worded. Biases, if any, may also be detected if the respondents have tended to respond similarly to all items. That is, they have stuck to only certain points on the scale. Always remember that if there is no variability in the data, then no variance can be explained. So getting a feel for the data is thus the necessary first step in all data analysis. Based on this initial feel, further detailed analysis may be undertaken to test the goodness of the data. And also, researchers go to great length to obtain the central tendency, the range, the dispersion, and other statistics for every single item, measuring the dependent and independent variables, especially when the measures for concepts are newly developed. So now let's talk about the frequencies. Okay, so how to do a frequency analysis? Frequencies simply refer to the number of times various subcategories of certain phenomena can occur, from which the percentage and the cumulative percentage of their occurrence can be easily calculated. Okay, so let me demonstrate how to do frequency analysis using SPSS software. So now let us demonstrate how to do frequency analysis using SPSS software. You try to go to this analyze, press this analyze button. So once you press this analyze button, you have descriptive statistics. From there you go to frequency analysis. So whatever the variables you would like to test the frequency, what you can do here, like I'm just putting this 3 variables here. Let me put this gender here. Okay, so I put this gender here, and sometimes I may require some charts, so I go for pie chart. So I press frequency here and continue, and I just press this OK, hit this OK button. So once you hit this OK button, you will get the frequency of this gender table. You can see male, female, the frequency and the percentage has been given. So frequency, male below 122 respondents are there, and female you have 177. Like this, you can very well employ SPSS software to run the frequency analysis for your data. So now let us also look at the descriptive statistics followed by frequency analysis, which is called central tendency and dispersions. Okay, so what we are going to do here, what we will be learning in this descriptive statistics, there are three measures of central tendency, that is mean, median, and mode. We all know, I think we have learned this concept from our childhood. So when you look at that, measures of dispersion include the range, the standard deviation, the variations, where the measure of central tendency is the mean, and the interquartile range, where the measure of central tendency is the median. So first, now let us look at the measures of central tendency. That is, first one is, let us look at this mean first. Okay. So in mean, the mean or the average is the measure of central tendency, that offers a general picture of the data without unnecessarily inundating one with each of the observation in a data set. For example, the production department might keep detailed records on how many units of a product are being produced each day. However, to estimate the raw materials inventory, all that the manager might want to know is how many units per month on average the department has been producing over the past 6 months. This measures of central tendency, that is the mean, might offer a manager a good idea of the quantity of materials that need to be stocked. So the mean or average of a set of say 10 observation is the sum of the 10 individual observations divided by the 10, the total number of observations. Next one is, let us also talk about the median. The median is the central item in a group of observations when they are arrayed in either an ascending or a descending order. Let us take an example to examine how the median is determined as a measure of central tendency. For example, in some cases, like on understanding the median, we just look at this example which is displayed here, which will give you and also demonstrate what is the meaning of median. And the next one is the mode. In some cases, a set of observation does not lend itself to a meaningful representation through either the mean or the median, but can be signified by the most frequently occurring phenomenon. For instance, let us take in a department where there are 10 white women, 24 white men, and 3 African American women. So, and 2 Asian women. The most frequently occurring group that we call it as the mode is the white men. Neither a mean nor a median is calculable or applicable in this case. Hope with this small example, hope you understand what is the meaning of the mode, median, and also the mean. Are you clear about it? Now let's go in detail about the measures of dispersion. So let's understand what is measures of dispersion. In measures of dispersion, we have 3 things. One is the range, variance, and standard deviation. Okay, so now let's understand what is range. If you ask me what is the range refers to the extreme values in a set of observations. The range is between 30 and 50 for a company a dispersion of 20 units, while the range is between 10 and 70 units, I think a dispersion of 60 units here for company B. I think this will tell you what is the range. Another more useful measure of dispersion is the variance. Let us understand what is variance here. So if you look at this displayed information, let's understand the variance is calculated by subtracting the mean from each of the observations in the data set, taking the square of this difference and dividing the total of these by the number of observations. Let's take the earlier example here. So the variance for each of the two companies are, you can see that the variance for company A, variance for company B, I think it is very clearly depicted here. As we can see, the variance is much larger in company B than when you compare with company A. This makes it more difficult for the manager of company B to estimate how many goods to stock than it is for a manager of company A. Thus, variance gives an indication of how dispersed the data in a data sets are. So, and moving further, let us also understand the third element called standard deviation. So what is standard deviation? So when you look at the standard deviation, which is another measure of dispersion for interval and ratio scaled data, which actually offers an index of the spread of your distribution or variability in the data. We will be discussing about the measures of dispersion. In this context, the standard deviation, which is another measure of dispersion for interval and ratio scaled data, offers an index of the spread of a distribution or the variability in the data. It is very commonly used measures of dispersion, and it's simply the square root of the variance. For example, in the case of the above two companies, what we have discussed earlier, the standard deviation for company A and B would be square root of, that is 66.7, and square root of 600, or 8.167 and 24.495 respectively. So the mean and standard deviation are the most common descriptive statistics for interval and ratio scaled data. The standard deviation in conjunction with the mean is very useful tool because of the following statistical rules in a normal distribution. Practically, all observations fall within 3 standard deviations of the average or the mean. More than 90% of the observations are within 2 standard deviations of the mean, and also more than half of the observations are within 1 standard deviation of the mean. So with this, I have given the right input to make you understand about the measures of dispersion. One is the range, variance, and also the standard deviation. Now let's move further to understand the testing the goodness of the measure. Any instrument you develop, it should have, follow this condition. I mean, it should fulfill this condition. Whenever you develop an instrument, make sure after entering your data, this data should be checked with this reliability and validity of the measures, so that then we can say that this particular instrument has followed the goodness of measures in research. Let's talk about the reliability. Let us understand what is reliability here. And here there are many reliability methods, but I am going to only talk about what you call the Cronbach alpha method of reliability testing. And of course, I will also demonstrate how to do that using SPSS software. So the reliability of a measure is established by testing for both the consistency and stability. When you ask me consistency, which indicates how well the questions or the variables measuring a particular concept. Let's talk about service quality. We have 5 dimensions and 22 variables. You can Google it, which is developed by Parasuraman and Zaitmal in the year 1998. Service quality questionnaire developed by Parasuraman and Zaitmal. You can Google it. You will get that questionnaire, which has 22 items and 5 dimensions, and it is measuring a concept called service quality. And if you look at that questionnaire, and after data collection, if you test that, the reliability, Cronbach alpha reliability, that we call it as a reliability coefficient, that indicates how well the items in a set are positively correlated to one another. So the Cronbach alpha is computed in terms of the average intercorrelations among the items measuring the concept, and the closer Cronbach alpha is to 1, the higher the internal consistency reliability. So now let me demonstrate that through this using SPS. So using SPSS, what you have to do in order to check the reliability, whether your instrument is consistent or not, whether your data is highly reliable or not, what you have to do, you go to analyze, go to scale, and you have a reliability analysis. And whatever the instrument questions, I have a data about the post-class preference of a flipped classroom. So on the flipped classroom, pre-class behavior, I'm checking, I'm trying to check the reliability of this because I have a data set pertaining to flipped classroom on students' behavior. So let me check that one. Let me put all these variables which is talking about pre-class activity and post-class activity. So when you talk about the flipped classroom, so you have pre-class activity. So let's put that pre-class activities of the students' perception. We have captured using this data, and I am trying to put that all those variables items, and I'm looking at this is the Cronbach alpha method. I just hit OK. So what happened, you can see the reliability is 0.950, which is excellent for the 16 items. So we can see to that the internal consistency is met using this test, okay, for this particular data and the instrument. Next one is let's talk about we call it as this I have demonstrated, and there is one output also I have shown you here. And let's talk about the next component is called validity testing. And in validity testing, we have factorial validity. For example, if your instrument has to abide by these conditions. So let us understand what is factorial validity. Factorial validity can be established by submitting the data for factor analysis. So what happens here, the results of the factor analysis, that is a multivariate technique, will confirm whether or not the theorized dimensions emerge. So this dimensions has been accumulated by doing a lot of literature reviews, and we take those items and we collect data and we try to explore using EFA, exploratory factor analysis, and the data get there are certain variables which will correlate, and so there are certain variables which repel and form individual dimensions or factor. That's the mathematical thing happening in factor analysis. The measures are developed by first delineating the dimension so as to operationalize the concept. Factor analysis reveals whether the dimensions are indeed tapped by the items in the measure as theoretically developed or not. Criterion related validity. Let's talk about criterion related validity. So in criterion related validity can be established by testing for the power of the measure to differentiate individuals who are known to be different. That is called criterion validity. It means that whether the the items which we are trying to put in the instrument is able to differentiate from one concept to the other. I mean, the one perception of the individual to the other perception of the individual. So that can be highlighted here. And the next one is let's talk about convergent validity. So convergent validity can be established when there is a high degree of correlation between two different sources responding to the same measure. Let's take the example, both supervisors and subordinates respond similarly to the perceived reward system measure administered to them. So that is the two perception of these both category of people, supervisor and subordinate, converge towards the perceived reward system. Then that concept is called convergent validity. The next one is, to check the discriminant validity can be established when two distinctly different concepts, isn't it, are not correlated to each other. Example, courage and honesty, leadership and motivation, and attitudes and behavior. Or these are the three different concepts, and the variables pertaining to each concept has to repel, and within that courage and honesty concept, the variables pertaining to that particular concept has to correlate with each other, and it should repel the variables which is responsible for courage and honesty should not correlate with the leadership and motivation, because it should have some kind of perceived difference, and so that's why it is called discriminant validity. Hope with this we have understood how to enter data, code the data, and how to do data preparation through this input, and how to perfectly develop an instrument using reliability and validity testing, how to confirm an instrument using reliability and validity testing. Thank you so much for listening to my inputs. Thank you very much. Good day.